Hello guys. So in this video we will talk about the solution of this Atcoder problem. It is from Atcoder regular contest 218. The problem is all minus. So first let's talk about the question. There are n non-negative integers a1 to an written on a blackboard. Alice and Bob play a game. Starting with Alice, they alternatively perform the following operations. The player who reduces the number of integers written on the blackboard to 0 wins. So this problem is about a game in which on a blackboard there are n non-negative integers are written. Alice and Bob are two people who will play this game. Alice will start the game. So basically n non-negative integers are written on the blackboard and Alice will come and he will remove some numbers. Then Bob will come, he will remove some numbers, and the person who will remove the last integer written on the board, I mean to say that if let's suppose five integers were written initially and Alice came and he removed four integers and one integer was remaining, and Bob came and if he removed this last integer, then Bob will win, and if Alice will remove the last integer, he will win. So how we can what are the operations that Alice and Bob can perform is defined here. So let's read it. Let m be the minimum non-negative integer currently written on the blackboard. So m is the minimum non-negative integer currently written on the board. So basically m is the minimum integer that is written on the board. So first, if m is greater than 0, if m is greater than 0, choose a positive integer x between 1 to m inclusive. Replace every integer written on the blackboard with its current value minus x. So this is one operation that we can perform, and if m is equal to 0, erase one or more of the zeros written on the blackboard. So these are the two operations. Determine who wins when the player play optimally to win. T test cases are there. N is also provided and AI will be given. And the sum of all test cases is at most 2 into 10 to the power 5. So that means we can go up to n or n root n or n log n solution. We cannot go n square. All input values are integers. This is the input format. And we have to output who will win. So this is a very good question of game theory. Initially, when I looked upon this question, I was confused as there was many cases to solve. But when you will write all the cases calmly, you will find out the solution. It is an easy question, I will say. So let's discuss the solution. So let's assume initially there are five integers written on the blackboard, and these are those five. Hmm. So these are the five integers written on the board. I hope you all can see it well. So first, Alice will start, and what Alice will see that 0 is the m is equal to m should be the minimum in non-negative integer in this blackboard. So m is equal to 0 here, and if n is equal to 0, we can remove either 1 or any number of zeros we want. So as there is only one zero, we have to remove it. So Alice comes and remove this 0, so that this 0 is removed and we will left with these four integers. Then Bob's turn will come, and Bob will come and the minimum non-negative integer here is 1. So 1 is greater than 0, so Bob can choose any integer between 1 to m. So here only one possible case is there, that Bob will choose 1 and replace every integer with integer minus x. X is the number that Bob will choose. So Bob can only choose 1, so these are the number that will be left after Bob's turn. So now Alice, let me write here whose turn was this. This was Alice turns. This was Bob's turns. Now Alice turns will come. Alice's turns will come. Then Alice will come and see again a 0 is there. So Alice will remove this. Then the numbers will be 1, 3 and 4. Then Bob's turn will come. Bob will again see a 0 and remove this. So now Alice chance will be there. Bob will see this one and subtract every integer 1 from it. So 0, 2 and 3. Now Alice will again remove this 0. Then Bob will get these integers. Now it is on Bob. Now it is on Bob that what he can choose, because here the minimum integer is 2. So Bob has two choice. Either he can choose a 1 or he can choose a 2. If he chooses 1, the integers will become 1 and 2, and if he chooses 2, the integer will become 0 and 1. So let's assume uh, Bob chooses x equal to 2. Then for Alice, these integers will be remaining. Then Alice will remove this 0. Then for Bob, only 1 will remain, and Bob has to make it 0. Then Alice will remove this last 0, and so Alice wins. But here I have not think of the optimal play. I have just given an example that how this game will work. So there are many cases, but I will make some of my claims and some good observations that will help us to solve this question. Because in these type of game theory questions, we have to first understand the game and find out the obvious conditions that are so easy to understand that get you can make those observations by understanding those easy and last, basically I will say that end state, or the obvious states, like if the array will contain only zeros, then I can say that simply Alice wins, because Alice will come and he will remove all the zeros, so Alice will win. And one more observation is that if let's assume the array contains some values like uh, 1, then it is for sure that Bob will win, because what will happen that Alice will come and he will have no choice than to remove this, to make this 1 to 0, and Bob will remove that 0. So from this we can also deduce that if the array is like this 1, 2, 3, 4, 5, then also I can say that Bob will win. Why? Because Alice will come and make this array to 0, 1, 2, 3, 4. Then Bob will come and he will remove that 0. So this array will transform into this. So now again else move will come. Then Alice will again make this 0, 1, 2 and 3. Then again Bob will come and remove that 0. Then the array will be like this. And at last, similarly at last 1 will be left, and when 1 will be left, then Alice will make it this to 0 and Bob will remove, so Bob will win. So these kind of array are obvious that Bob will win. So these were the first three observations that I made. Basically, now I will generalize this. So in this question, the important thing is you don't have to focus on the goal, that what will be the last integer that will be left and whose chance will be there. We can simply say that if we find any of these conditions, the person, let's assume the game is going on and we got to a state S, and this S, who will make the move on this S will win. This for sure he will win if he has the chance to move on this state. Uh, yes. So basically both the players will try to get this S, so that they will want that before this S, the next player's turn is there and they have to perform the operation on this S so that they can win, right? And basically after these S the game will end. So what we can do that we can see that here we have many choices. The choices are like that basically the power of choices you can say because we know that this condition is very important, that erase one or more number of zeros. So one, this condition will help us to change the turns. And another thing is that like uh, if let's assume you have a uh, 2 written on the board, then and you are going to perform the operation, then you can do two things to make it 1 or make it a 0. Similarly for any integer greater than I would say 1, any m greater than 1, you have a choice to make it 1 or a 0, right? Because if m is equal to 1, then you have to perform operation, you have to make it 0. So you have no choice here, but you have choice here. And another choice is that you can remove the number of zeros. So my first claim is if the set if the array, I would say if the array has only one zero, then Alice will win. This is self-explanatory, as if only one zero is there, then Alice will come and remove it and he will win. My second claim is that if array at any moment contain two or more zeros and the player who have to the player whose turn is there the player whose turn is there will win. Why? Because like for example Alice is going to make the turn and there are let's assume three zeros present in the array. So one possible case is that if Alice will remove all the zeros, then he is going to lose. Let's assume this. Forget what will happen afterwards. Just assume if three zeros are there, and if Alice removes the three zeros, he will 100% lose. So what Alice can do? So Alice knows that if he will remove three zeros, then he will lose the game. So he will not remove the three zeros. He will remove only two zeros and leave the last zero for Bob. So Bob will be the one who will remove the last zero. And so ultimately it is equivalent to Bob removing the three zeros. So we can say that this this particular state is a winning state for us because we will decide what action we will perform. If assume that if after removing if three zeros are there and if Alice will remove the three zeros and he will win, then he will remove the three zeros. So this is one condition. Another condition is that if m is greater than equal to 2, then the player whose turn is there will win. Why? Let me correct it. Why? Because let's assume that the least number that is present on the array is 2. So what will happen? Now I have a choice that if I make this 2 to 0, then I will lose. Then I will not make this to 0. I will transform this m to 1 so that the next player will make it 0 and he will lose. And if by making it 0 I win, then I will of course make it 0 so that I can win. So these are the important conditions uh, so that we can find out who will win or not. So this was a very interesting questions. Let's look at the code now. So what I have done, I have taken an input and I have taken the array as the input. Then the obvious case that if n is equal to 1, and this is a special case that if the array contain ones, then I have no choice. I have to make it 0, and the next person will be coming, will remove it, so Bob will win. This is the first case that I thought that, so that's why I hard coded it. Then I have basically counted the frequency of every element that is coming. And if this is the interesting case, if initially the count of 0 is greater than equal to 2, so the first person Alice is going to perform the move, so Alice will win. But now, if assume let's assume that the array initially does not contains the count of 0 more than 2, and it is 1. So it is basically saying like the first person will go, and if the 0 is present, he will remove that 0. And if Alice is the first one who is going to perform the actions, and there is 1 0 present in the array, then Alice will remove this 0, and so the Bob's turn will come next. So basically what I have done here, that if the key was 0, then I have continued because I have handled this case in this if. Then if key is equal to 2, I have increased the value of t. uh, this condition is for securing this condition, because like if we get a number like this, then this will form a chain action, because I will remove this one, then this. I have no control on this whole length. So I have basically increased the value of t. But here is a special case. If the value is greater than equal to 2, let's assume here I had two twos, then what would have happened? I have, let's think Alice case is there. Alice chance is there. So Alice will come and transform this to 0, 1, 1. And after that, what will happen? Bob will come and Bob will remove that 0. Then Alice again will come, and as these 2 will be changed into 1 1, he will reduce these both ones to 0, because he have no choice. Then Bob will get two zeros, and we have already said if anyone will get more than two zeros, then he will win. So that's why I have written that whoever will perform the second operation will win here. And if it is not the case, this case is done, then this else part is there, that if the we are performing like we are getting this, if I remove this 4, then here a break will be there, because what will happen when this 3 will become 0, this 5 will become 2, and whosoever gets this 2 will win. So that's why I have written this condition. First person moving this will win. And if after all this I didn't get a winner, that means all the integers are gone and it is a chain. So the second person will win. So the time complexity of this code is n log n, because I have taken the input and I have used a map for every equation. So it is n log n. Space complexity is also n. So this is the solution. Thank you.